Hello guys, welcome to my channel Civil Softwares. Today we are going to model these two trusses in SAP 2000 and we are going to run the model and see the actual force diagram of these trusses. At first, let's model this truss first. So let's go to SAP 2000, then let's open a new model. Okay, now here we can see the model. At first, we need to set the units kilonewton, meter, and Celsius. For now, let's not do anything over here. So let's select these units and let's go to grid only. Now for this, let's go to the question, and in X direction, we are having 1, 2, 3, 4, 5 grids. Okay, so let's go to X direction. Let's keep 5 over here. In Y direction, we have nothing, so let's just keep 2 over here, and in Z direction we can keep 1 for this and 2 for this. So let's keep 2 over here. Now as far as the spacing is concerned, let's give some spacing over here. If you want to edit it later on, we can. So in X direction, let's see the grid spacing. It's 20 20 20 each, so let's keep 20 over here, 20. And in Y direction we have, it does not even matter, so let's just keep anything like 2. And in Z direction, let's see, Z direction is also 20, so let's go to Z direction and keep 20 over here. Now let's click on OK. If we want to change the grid, we can just edit from here too. So we have cross something like this. So in Y direction we kept 2 grid lines, so it has these 2 lines over here. If you want to remove this, you can just go to edit and go to edit grid data. We can go to edit grid data, and we can just change this coordinate system and grids. Okay, so modify source system, we can go over here, and then we can just delete this one Y grid and click on OK, then click on OK. So if we do this, it is going to give us the single 2D structure. Okay, now this is XY plane. Okay, so now let's see this spacing again. If you go and click on right click on mouse and go to edit grid data and modify, we can go over here, and now let's see if the spacing is correct. 20 20 20 20 and 24. Do we need any changes over here? I don't think so. It is in ordinates. I've already explained about how we can set ordinate grids and spacing. So if you click on spacing, you can see 20 spacing for uh, all the X grids, and for Z it's 20, so it's absolutely fine. We don't need to change anything, so click on OK. Now this is XY plane, so we are only seeing one line over here, but we need this XZ plane for applying our loads. So we will just click on the XZ plane so that we get XZ plane like this. Now what we need to do is we need to add these members over here. So now let's go to the draw frame cable. Okay, now here it is a straight frame, so it's okay, and section, it's okay, because we are not defining any sections on our own. We are just keeping the self with multiplier 0, so this does not matter. So moment releases, we'll keep continuous for now. I'll explain what continuous and pinned difference is also. So for now, let's just keep it like this. Okay, now we will add the members over here. So see the structure at first. Okay, now from here to here, then from here let's go all the way to here, then from here go to here, After you are done, just click on escape. Now again we need to draw the intermediate sections too, right? So just see in the picture, okay, goes that way, go here, here, then here to here. Then we also have this kind of structure. Is that done? Okay, one more member is over there. So let's just go and add this member too. Okay, so our truss is like this. Okay, now we are going to give the restraints over these 2 points. So let's select this point, and here we have hinge support, and here we have roller, hinge and roller. So here we're going to define, we're going to assign, what we're going to assign, we're going to assign joint restraints, and we're going to keep hinge over here, apply. Okay, so there we get hinge support. Similarly, at this point we need roller support, so click on roller, apply, click on OK. So we are done with our restraints and we have modeled this, but now we need to apply the loads. So you can see point loads of 3 kilonewton on this bottom face. That's all the loads that we've got. So 3 kilonewton. Okay, so now go to this point and let's select this member, because we are applying the load on this member, right? 3 kilonewton over here, 3 kilonewton over here, and 3 kilonewton over here. So right click on this point, and here you can see there are no loads because we have not applied anything. But as soon as we apply, here you can see all the loads that we apply. So click on this point, now assign, go to frame loads, then go to point load, because we only have point loads over here. Now there's one relative distance and absolute distance, right? So we are going to select absolute distance over here. So at 0 we do not have any load, and these all spacing are of 20 units each. So at 20 we have 3 kilonewton load, and in another 20 we have 3 kilonewton load. This is absolute distance from end I, right? So 20, if you click absolute distance, it calculates from this initial point. So up to here it's 20, but at 40 we have, at 40 we have 3 kilonewton, and at 60, 60 means 20, 20, 20. We get up to this point at 60 units. So go to 60, and we are going to assign 3 kilonewton load. So that's all the load we have. You can also click relative distance and do, but I chose to do this. Click on apply. You can do any process. Click on apply. Okay, here you can see 3 kilonewton is downwards, downwards, downwards. That's what we wanted, right? So click on OK. So we are done with our modeling. We have applied the loads too. Now what we are going to do is we are going to run this model, right? We're going to run this model. So now I have I said that I will explain about what continuous joint and pin joints is. So if you we have previously selected the continuous joint. Okay, if you remember, when I went here, and here there was option to choose continuous or pin, but I chose continuous. If you choose continuous, that means these points, these points, these points, these points, these are fixed. They are not pinned. Okay, they are fixed. If you keep continuous, it means they are fixed. These joints are fixed, like welded. Okay, they have movement uh, resistances over here if you choose continuous. But if you choose pin support over here, it acts as hinge support. Okay, hinge support, which cannot resist the movement. Okay, so that's the difference, between continuous and the pin support. So for now I've chosen continuous support. So now let's run this model. Okay, so let's go to run this model, And okay, before that, we should not forget that when we go to define and we go to load patterns, we should keep self-weight multiplier at 0, because we are only interested in knowing how this load behaves on this structure. We are not interested about the sectional properties. We are not adding the self weight of the structure because we have not defined any, right? So we're just going to modify load pattern. So keep 0, click on OK. So now we are going to run this model, run analysis. Now we are only going to run this dead load, not model. So in model we do not run this case. Okay, we are only going to run this dead load case. So now click on run now. So for now we have to save it. Okay, at desktop, let's just save with any name, process. Okay, save. Now it is going to run the model. Here you can see the loading bar. Okay, so this is our deformed shape, right? Here you can read different kind of warning messages and all. This is nothing. Okay, because there are 0 errors, no errors. So done. Now, so if you want to see the animation, you can just click on start animation and you can just see this. Okay, stop this. Now what we are interested in is about the uh, diagrams, axial force diagram. So go to this icon over here, then let's go to joints. If you want to see the end reaction, okay, you want to see the end reaction, so go to joints. Okay, now when you go to joints and you click on apply over here, because everything is okay. Okay, click on apply, then you can see the reactions of 4.5 kilonewton and 4.5 kilonewton upwards. This is correct because we applied 3 kilonewton, that makes it 9 kilonewton. So we have reactions of 4.5 4.5, that makes 9. So it's okay. If you click on tabulated form, it's going to show in the value form, right? So it's okay, but arrows, it's good because it also shows the direction. So click on OK. So now if you want to see the axial force diagram, you can go to frame cable sections. Now this is axial force, so let's click on apply. So this is our axial force diagram. Okay, now if you want to look at any of these members, and so the details of the axial force diagrams values, just go and click to the member, just right click on that. Okay, then you can see this detail. So here you can see different kind of things. So it's resultant axial force, resultant torsion force, everything you can see over here. Okay, so this is how you can see the individual members values over here. So for example, if I want to see the details about this member, you can just go to this member and click on it and right click on it. So it's going to show you that member only. Okay, so you can just go to any member and just right click it, then you can see details about your members, whatever you want to see. Okay, then this way you can model the truss. Now let's go and solve another question. This question, we'll solve that in next video. Thank you.